So we are excited to have this session brought to you by the Wildfire Commons. And what is also exciting from the Wildfire Commons will be that the end of July, July 31st, we're going to have our launch event. So we'll talk a little bit about that event at the end of today's session. But as our waiting room starts to die down, we'll go ahead and just introduce our lead speaker. So Ann. So Ann is coming from Earth-Fire Alliance, which is a championing new era of wildfire monitoring tools and technology. Their flagship program, the FireSat constellation, which will deliver transformative and near real-time wildfire detection and monitoring to first responders, incident commanders, and scientists around the globe. So we'll hear from Ann today on their early adoption and community engagement lead in their program there. And she'll be talking to the missions that are underway for the FireSat program and how the community can become involved as early adopters as well. And I see that we do have a pretty good quorum. So with that, Ann, if you would like to take us away, the floor is yours.
Awesome. All right. Well, thank you very much, Claire. And I just was saying that I wanted to start off by just thanking the Wildfire Science and Technology Commons for inviting us to present today. Really excited to talk to you all about Earth-Fire Alliance and the FireSat program. So as Claire said, my name is Ann Kapusta. I am the Community Engagement and Early Adoption Lead for the organization. Sorry, I just got a notification. I don't think that popped up though on the screen. So anyway, and I have been with the organization for a couple of years now. I'll go through a little bit of the timeline, but we've got a history founded in working with philanthropic partners to listen to the user needs and establish the program. And I've been involved with the program all along. So happy to answer any questions, but hopefully we'll give a good overview of the Alliance, our mission, the FireSat program, and the early adopter program today. So I know I've got a short amount of time and a lot to cover. So just to give a little bit of framework of the conversation and how I'm going to go through it today, I'm going to start with kind of who we are. So for those of you unfamiliar with the Alliance, our purpose, mission, and vision, and our approach, I'll go through that. Then I'll move into what is FireSat and what's our flagship program, again, for an intro for those of you who are not familiar. Then I'll go through a little bit of where we've been and where we're going. So it's really important to understand the timeline and how fast we're moving, but that there's a lot still on the horizon ahead of us. So I'm going to go through that. And then finally, how radical collaboration will get us there. So one of our core beliefs is in radical collaboration and working with the community to get this data out there and adopted. So we'll go through that, which includes the early adoption program. So moving right along, who we are. So I always like to start with our grounding philosophy of Earth-Fire Alliance, our purpose, mission, and vision. So Earth-Fire Alliance is a global nonprofit, California-based, but global in nature, that's founded on the belief that high-fidelity data, equitably accessible on a global scale, will transform our collective approach and relationship to fire. We do this through our mission of observe, serve, and conserve. And that's basically observing all of our planet's wildfires comprehensively and equitably, serving that data to the communities worldwide with timely and trustworthy information in an effort to conserve our ecosystems and biodiversity by informing resilience strategies. And overall, our vision is that we believe a united response to the wildfire crisis is possible, and that data-driven information will expand our focus and funding from the reactive suppression to a more proactive stewardship that involves and includes adaptation and beneficial fire practices. So I always like to start with that because it really grounds us in why we're here and what we're doing and who we are as an organization, and why we were founded to make sure that we're both collecting this data, but also working with a community. Having Alliance in our name was really important. We're working as part of this community and as an organizing body to make sure that we're really understanding fires and understanding our relationship with fire and trying to restore that balance. We also have some key operating principles that drive us on the daily, drive our team on the daily. So that's fast action, and that's not just about getting the data into the hands of people as quickly as possible, but that we also need that data to be fresh and reliable. So fast action is one of our core principles, as well as transformative fire data. So when we collect this data, we understand that there's more to fire than just detecting where hotspots are. It's really about understanding all stages of the fire life cycle, understanding what's happening within fire boundaries, and understanding what's happening in the environment pre and post fire as well. So we believe that transformative fire data is inclusive fire data. We also believe in user-driven technology, so making sure that we're collecting exactly what's being asked for and delivering it in the manners and mechanisms that make it easy to ingest for those on the ground. And then finally, I alluded to this already in the agenda, but we believe in radical collaboration. So there's a lot of people out here trying to work towards the same goal. And we believe the fastest way to get there is by aligning these collective efforts, whether that be in technology or resources or communities, with and across sectors for a global common good. It's one of the main reasons why I'm really excited to be here today talking to this community, is that kind of shared philosophy of aligning collective efforts on this. So when I talk about user-driven technology, this stems from a history in the program of really connecting with hundreds of users around the world on what fire data exists, what's being used today, and where there are sort of gaps, and where philanthropy can really fit in to fill those gaps that we heard from the community. So at the end of the day, when we talked to the community, we really came up with there were two major groups of fire data end users and two driving needs for these two groups. So the first is in the frontline and incident commanders, the boots on the ground, those who are fighting fires to protect ecosystems and communities. And really what they needed is fresh, fast information about where new fires are, how fast they're moving, and how hot they're burning. So just this new era of fire necessitates a faster and more timely data access for those on the ground to make more informed resource decisions. And on the modeler and scientist side of the house, it's really about a continuous data collection and a uniform data collection on all fire stages, including pre and post fire analysis. Additionally, from the carbon and climate scientists, there's just not that consistent data source for understanding comprehensive carbon stock monitoring when it comes to wildfires, which is a very complex process because it both generates carbon, but it also creates carbon stores in fire-adapted ecosystems that kind of regrow forests based on fire needs. So really, at the end of the day, listening to these two requirements, it was really about a global data collection and a consistent and reliable and accessible data collection for kind of all fire user communities in order to be able to compare and understand really what's happening in the environment and what's happening with fires. We also believe as a nonprofit that equity is transformative. We believe that we need to give the fire response community this data in order to inform what they're doing. And we remain committed to making our fire data products equitably accessible and free of charge to the agencies around the world who protect their communities. We firmly believe that this data is a resource and that it needs to be out there in order to better inform more resilient strategies, more effective evacuations, more effective fire response strategies, and more effective land management strategies. And so we truly believe that this data needs to be out there, very akin to weather data on your phone and being aware of the situation and what's happening with wildfire. And we know that there are going to be immediate impacts of having this type of transformational, timely, and consistent wildfire data. We believe that data from before, during, and after wildfires can reduce destruction, track and record the path, and understand near and long-term impacts on communities and ecosystems. And this is true kind of across the board when you're looking at whether that be communities at risk. We can provide earlier warnings and protect communities and inform resource deployment. We can protect fragile ecosystems that are being impacted by fire. and monitor that progression and understand really, what we can do for mitigation strategies to protect vulnerable ecosystems. As I said before, measuring the climate impact is really important. Quantifying, what impact wildfires are having on emissions globally, and having a better understanding of that stock and monitoring of that. And then finally, understanding the impacts of mitigations. So there are a lot of things going on, probably preaching to the choir with this community of a lot of mitigation and resilience strategies, but how do we actually measure the effectiveness of those? And how do we put better, build the conditions in order to create better fire management resilience strategies? Okay, so that was a super briefer of who we are as the Alliance and our vision and mission. But the big question is how? How are we going to get there? What are we going to do about this? We've learned from the community. We've got this great nonprofit set up, but what are we actually going to do to address the problem as a nonprofit? So next I'll go into our solution, which is FireSat, our flagship program. So the first part of the slide was about Earthfire, or the first part of the presentation was about Earthfire Alliance, which is the global community-led nonprofit and the home for FireSat. FireSat is the Alliance's flagship program, which is a space-based fire detection and characterization system designed specifically for wildfires to provide that timely and trustworthy wildfire activity directly to agencies around the world. So a little bit more about FireSat. FireSat is a satellite constellation that was built specifically based on the user needs from the wildfire community. So it is wildfire focused first. And it is built to manage and monitor wildfire starts, wildfire conditions, and wildfire's ecological effects. It's designed to provide a consistent, accurate, and comprehensive view of fire activity globally. And we do this because by deploying it in a low Earth orbit constellation, and each one of our satellites is equipped with a multispectral imager that will provide the unprecedented spatial and temporal coverage for wildfires around the globe. Earthfire Alliance is the founding nonprofit home. FireSat is the program within Earthfire Alliance, and Muon Space is our technical collaborator who is building the first three constellations, or the first three satellites of the constellation, plus the FireSat 0. So a little bit more about the system. So what do we mean when we say that we're a satellite system collecting fire data? We are building a series of satellites that fly about 600 kilometers above the Earth, giving us an 80-meter average resolution for fire detection across the globe. So basically, whenever the satellites pass overhead, as you see in the image over there on the right, and detect a fire, we'll characterize that fire and pass that data down to the ground via a high-speed downlink to get it into the hands of people on the ground within minutes of initial collection. The detector also has the ability to do sub-pixel detection, so we can actually get down to 5-meter by 5-meter resolution for detecting hotspots. And that can either be new fire starts or new fires within existing active fires, or even monitoring fires after they're contained for any new starts or any new restarts. We also have a very low false positive. We heard from the community that if we don't keep our false positive low, it's not a usable system for operational users, which makes sense. So we did this by measuring in 6 different wavelengths, 5 different wavelengths across 6 different spectral bands, which reduces our false positive and allows us to see fire in a variety of different conditions, through smoke at night, and at a variety of different temperatures and biomes. And then finally, the temporal resolution is also critical. So initially with our first launch of 3 satellites, we'll have a 12-hour revisit starting in 2026. And then we'll get down to a 20-minute global revisit by the end of the decade with the full constellation deployed. And that's for every spot on Earth that manages wildfire or that deals with wildfire. And then the data distribution on the side is really attuned to the variety of different users that will we'll be utilizing the FireSat data. So we have a variety of different downlinks and data access channels to make sure that it gets into the hands of those that need it as quickly as possible, whether that be somebody on the front line or somebody in a data center, doing data modeling or fire prediction modeling. So when I talk about the 5 different wavelengths, it's really across the full spectrum. So again, working with key fire scientists and fire researchers, understanding that we needed a multispectral simultaneous imager to really understand what's happening with a fire became a critical requirement for us. So we measure across the visible, the near infrared, the short wave, the mid wave, and the long wave bands. And this is data just from the NASA's master instrument to show you exactly what channels we'll see and kind of why we chose these specific channels. So this again is taken simultaneously, but you can see that the clouds really start to obstruct the view in the visible and near infrared. You can start to see the perimeter appear sort of in the mid wave and the long wave, and hotspots in the short wave and the mid wave and the long wave. So having all of these kind of brought together to be able to look at separately gives us that full characterization and full view of fire activity. And I will note that we do image in 6 channels across these 5 bands. So we actually have 2 channels in the midwave, and that's so that we can look at different biomes of fire. So, and that we don't oversaturate our detector. So basically we can look at grass fires or forest fires, which burn at dramatically different temperatures, and be able to see them with the same sort of fidelity. It also allows us to monitor both large, hot, fast-moving fires, as well as small, cooler, slower-moving fires, so that we can really kind of balance understanding of beneficial fires, even within naturally occurring wildfires. And then the temporal resolution is our other, kind of driving feature. And I talked about this with our principles in kind of fast action. It's not just getting this up there as quickly as possible, but also delivering the data in a timely manner. Hearing from the community again, especially the operational community, that scale data is not useful when it comes to deploying resources and understanding, immediate impacts on communities and ecosystems. So that really comes in 2 sides of designing, kind of the system and the FireSat system, and that's how fast we actually fly overhead of a region on Earth. So that's the revisit, which, as I said, will get down to 20 minutes when we have the full constellation. But it's not just that, it's how fast the data can actually get down to the ground as well, which is really a combination of the communication mechanisms on board of the spacecraft and the ground stations that can actually collect the data here on Earth. So we really wanted to balance these 2 things to make sure that we're not just passing overhead very frequently, but then not actually getting the data into the hands of those that need it in a timely manner. So the left shows our revisit of that 20 minutes and even down to as low as 9 to 12 minutes in some key fire geographies. And then the low latency that we're working with a ground station network that can get this data down to the ground within minutes of observation. And the other thing I'll note with the low latency is that even some of the regions that have a higher, that are more in the red region there, those can actually be mitigated with working with those communities to deploy ground stations in those regions. So we can actually change the capacity of the low latency on the ground as well as we continue to build out the capabilities of the system. And this is all well and good to think about what FireSat means, but a picture goes a long way, goes a lot further than kind of imagining what 8 meters looks like on the ground. So this is for illustrative purposes only. This is simulated data, but this is built off of essentially what FireSat would have seen if it was around when the Caldor fire happened. So this is about 30 days sped up, obviously, of data of FireSat at the full 50-meter resolution and 20-minute revisit. And you can just, it starts to give a taste of, what FireSat could have seen and what the resolution would be, sort of in this region. So you see it flashing kind of day and night, and then you see the, kind of fire progression. And again, this is just on the baseline brightness temperature measurements of simulated data. So again, none of the analysis, just what we would see based on simulations of VIIRS data, and then kind of filled in the blank. In addition to collecting the baseline brightness temperatures and fire data from the ground, we're also committed to delivering 4 key fire data products that we heard from the fire communities that are really needed for understanding what's happening in with the fire and what's happening in the surrounding region. So again, this is part of the equitable access to data. There are obviously certain regions that have geographic information systems teams and use remote sensing data and can kind of develop these products. But there are a lot of regions that are still using paper maps. And so we want to make sure that we're delivering the data in a format that makes sense to communities around the world to be able to use these products instantly. So as I said, in addition to the brightness temperatures, which was shown on the last screen, we're also going to be delivering fire perimeter maps, fire radiative power or intensity within the fire perimeter. So where's the hot front of the fire, where's the cool front, and hopefully help in informing better resource management and understanding of fire. Fire progression, which is really a historical rate of understanding, where the fire came from and how fast it's moving and where it's moving to. And we hope that will help to improve safety for the front line and for situational awareness of what's happening with the fire. And then the final one is hotspots. So I mentioned this early on, but identifying not just where new fires are starting, but where hotspots are popping up in existing fires. So this will come down in kind of small data packets with lat long and a confidence level that will work with the community to make sure that we're delivering helpful information on hotspots. And again, this all is well and good until you kind of see it compared to what exists today. So right now, the state of the art in publicly accessible satellite data for fire is the VIIRS system, which images at about a 375 meter resolution. And then GOES-R has the temporal revisit, or Huami if you're on if you're in the western side. So those are the geostationary satellites, which give you persistence over a fire, but not great spatial coverage. So they're about a 1 kilometer to 2 kilometer for their fire data products. And SWOMI VIIRS is a sun synchronous orbit, so you get collections at most every 12 hours. In some regions, it's only as frequently as every 48 hours. So this just started to show a little bit of the difference between the different systems and how FireSat is really that sweet spot between the temporal coverage and the spatial coverage that no other existing kind of publicly accessible system provides today. Again, this is just sort of that, but in a visual representation, in a graph instead of a video representation, but shows you kind of the major systems that are out there right now, their revisit, and how FireSat compares. The only reason I added this one in there is because it also highlights MODIS, which I'm sure a lot of you are familiar with, the Terra and Aqua satellites. That's a 500 meter resolution, but is sunsetting here in the next year. So we'll actually lose capabilities with MODIS as we're building FireSat up, but we hope to be able to do our part in covering that gap as quickly as possible. And finally, we know that FireSat is not a silver bullet solution. There's a lot more data on fires that we need to have at the hands of those who are out there on the front line, or those who are the scientists kind of understanding what's going on. And so we believe we're part of a remote sensing ecosystem, and that FireSat is a key component of baseline, consistent, reliable data, but where other systems can feed in additional data sources as needed in times of fire activity. So everything from aircraft observations for rapid intelligence and surveillance to ground cameras, which are always on, but at a horizontal monitoring in certain regions. FireGuard data, which some have access to, some don't, but classified national asset systems, and then eventually, building in FireSat as a capability to, to complement all of these systems and hopefully make everything a lot more functional in how they're used and how they're accessed, and building another baseline data layer for global wildfire data. Doing a time check. Okay, so halfway through, hopefully I haven't lost anybody yet. So the next two sections are really about the future, where we're going and what this means. So I'll start with a little bit of a timeline and then go into our radical collaboration opportunities and our belief with the Alliance. So where we've come from and where we're going, I'm going to lay out a quick, very brief history, but mostly around the capabilities of the system and how it's building up over the next couple of years. So pre-2025, before this year, there was a lot of foundation work laid for success with a lot of great organizations that have supported this effort for the better part of the last 3-5 years. So it really kind of broke down in 3 major categories pre-2025. And that was the feasibility and formulation study, understanding the end user needs and figuring out where philanthropy and a bunch of independent efforts, which had been started by organizations, how we kind of come together and kind of start this formation of the Alliance. Then there was the design and validation. So once we listened to the users and we understood what was out there, it was about how could we actually design the system and could we do it with the tools, technology, and resources that are available today. And that was done with our technical partner, Muon Space, who helped us design the initial requirements, the initial FireSat system design, and then validated by an independent technical assessment to make sure that we could move forward with the design. And then finally, it was establishing Earthfire Alliance. So Earthfire Alliance is only about a year old, and it was developed as the nonprofit home with the belief that this data needs to be equitably accessible, run through a nonprofit, but also being a home for FireSat as our flagship program to get that done. So 2025, where we're at today. So we launched, which is very exciting. So we had our first launch of FireSat 0, which is our test satellite, earlier this year in March from Vandenberg Space Force Base. We expect the first representative data from this instrument to be available later this summer. In addition, it's really important that we're not just building the technology, but we're continuing to build the community. So again, that user-driven principle that's behind Earthfire Alliance is a major component of making sure that this data gets out there as quickly as possible. So we've established an early adopter program, which I've got a couple of slides that go into more detail of that a little bit later on. But it's really a global program working with fire agencies and fire scientists around the world to accelerate the adoption of this data use in key wildfire geographies. And we hope to work with them to leverage some of the test data from this initial satellite to get the systems ready for the operational data. And then finally, we're going to get some representative packet data from FireSat 0. So again, FireSat 0 is a test satellite, but it's got a fully capable instrument. So the data that comes down off of it will have all the wavelength bands at the resolution. So it'll be a great way. It just won't come down in real time. So it'll be on a delay, and it won't be as consistent as the operational satellites. But it'll be a great way to test and provide feedback on the system before we get it ready for operational use in 2026. So now I have a couple of fun videos since we did actually launch. So this is the actual launch of the FireSat 0 onboard SpaceX transporter mission in March. So always fun to see a rocket launch, and it was a night launch, which was very exciting. So everything went off successfully, and then the next one is a very quick clip, but it's when we actually deployed the FireSat 0 instrument from the rocket.
FireSat 0 deploy confirmed.
So very exciting time for all of us, but we don't, everything with our program is we never stop. There's more work that always needs to be done. So 2025 is test, 2026 is operations. So in 2026, we will launch an additional 3 operational satellites in the FireSat constellation. They'll launch in mid-2026. We already have those launch spots confirmed. And that will give us daily data for select regions around the globe. So we're really excited about that. It'll actually give us twice daily. So it's going up in what's called a sun-synchronous orbit, which will basically pass overhead of the same region exactly 12 hours apart. And this will give us full resolution monitoring, hotspots, and the multispectral observations for select geographies around the world. And what's really exciting is that we're not just launching one satellite, we're launching 3. They're actually going up in a train that will give us 3 rapid succession observations before that train kind of passes overhead 12 hours later. So we'll also be able to start testing some of the capabilities of rapid observations that we'll get with the full capability instrument at the 20 to 30 minute revisit, even with this first launch of the 3 satellites. And then we're going to test some of the low latency capabilities of that as well in certain fire geographies. So before we build up the full capability and the capacity, we can't do this for every region, but we'll be able to start showing what the power of kind of up to the minute updates on fire activity in rapid succession are, even with the launch of our first 3 satellites. Moving forward, around 2028, we should get hourly revisit and global data access. So we'll continue to deploy the FireSat constellation in groups of probably 8 to 10 satellites per launch. And this will help us build the constellation capabilities systematically throughout the years while we're continuing to ready the ground network and the fire agencies and the ground station networks and the data distribution pipelines and everything that needs to be there in order for FireSat to be adopted. We can scale that up systematically over time as we also scale the capability of the satellites. So once we get to about half of the constellation deployed, which we expect to be somewhere in the 2028 timeframe, we'll get hourly updates in the mid-latitudes. So that'll increase the capability and also give us more regions that are getting that near real-time, low-latency global data access. And the early adopter program at this point will transition. So again, this is the capability that allows us to really onboard even more agencies as this data becomes more readily available as we build the capacity. So the use cases and the data systems and everything that we tested with our early adopter program participants will be used to systematically roll out to other agencies around the world that use similar systems or even the exact same systems, whether those be common operating pictures or data ingestion models or anything like that. We'll start using this to really scale up to a global capacity as we're scaling up the satellite constellation as well. And then finally, 2030 will give us our full operational capability. So that's when we launch the rest of the constellation, which gets us to the global 20-minute average and low latency downlink for all places around the globe. Also, we will transition into long-term sustainability. So it's not just launch and done, but there's a lot that goes into the maintenance and operations of a constellation once you get it up, including refreshing any satellites and making sure that the mechanisms are in place for long-term commitment to our mission and goal. So all along this timeline, we'll be working with communities and members of the Alliance to make sure that everything is in place from the end users, the technical capabilities, the funding, and the policy partners to make sure that this data is out there and sustainable for years to come. So in my last, I've got about 10 minutes left, and then I'd love to open it up for questions. So the last little bit, I'll go into a little bit more about what radical collaboration means for the Alliance, and a little bit about our early adopter program, which I've mentioned a couple of times throughout the presentation already. So first of all, a little bit about what the Alliance means. As I said in the very first slide, we were very intentional about using the word Alliance in our name. And it's really about a collective group of people coming together to make sure that it's a community-led approach, and that we all have a kind of role in making sure that this is successful. So We leverage that idea and we're building out the Alliance in addition to technical capabilities, because it's not just about the technology, but it's about the community and the adoption of data. So while FireSat serves the core capability to provide the data, the Alliance allows us to deliver on our mission to make sure that we've got it integrated into systems and into communities as quickly as possible. The Alliance really breaks out into kind of three major categories: end users, technical partners, and funders and policy partners. This is still very much early on. As I said, the Alliance is only a year old, but we're already working with some amazing people in each of these categories to make sure that we're successful, and we intend to continue to build out the Alliance with these communities over the next couple of years, over the next decade, as we continue to deliver transformative fire data. And again, FireSat is one mechanism to do that. There are plenty of other systems and mechanisms out there and things in the work. And so it's really important to us to continue this collaboration effort, with but beyond FireSat as well. So I wanted to introduce the Alliance mainly to zoom in on the early adopters. And as I said in my intro, I am the lead of the early adopter program and the user community outreach and engagement lead. So this is really in my wheelhouse. And the last couple of slides, I'll go into a little bit more specifics about this program and how it's really going to be a catalyst mechanism for enabling the use of FireSat data and building the Alliance up over the next throughout the next decade. So the early adopter program is really about working with agencies, fire modelers, and scientists. So those original users that we got the requirements from. So working with them in key geographies around the world to understand the systems they're using, ready those systems, and start to measure the impacts that this new era of wildfire monitoring will bring. So it's really about using this time where we're building the capabilities of the FireSat system to make sure that we're continuing to work with the community so they understand exactly what's coming down the pipeline and how those systems can be, ready to ingest this data as soon as it's operationally ready next year. So our three major goals for the program are to expedite use. So exactly what I said, reduce the adoption timeline by working directly with the end user community. And understanding the integrations, the data processes, the mechanisms that are in place, or how we can build mechanisms to get that FireSat data integrated and as useful as quickly as possible. One of our key philosophies is that we don't want to build what we don't have to. And so understanding what systems are in place and not developing another tool or widget or dashboard, but really integrating into the existing systems that are out there is one of our key, key components of, both the early adopter program, but also the FireSat program. So hopefully working with agencies in this, we'll start to understand that landscape and work with the technical partners, which are part of the Alliance as well, to ready those systems for the integration of FireSat data. Our second goal is about informed iterations. So this is really the continuous improvement and feedback cycle. So we built the system based on user needs and talking to the community, and we don't intend to stop that anytime soon. So the early adopter program allows us a mechanism to continue to get that feedback and make sure that what we're developing and providing is actually usable for the community. So whether that be refinement of those 4 data products that I talked about, metadata in order to make sure that the data is ingestible by the tools and systems that they have, or other data needs that exist in the community. We want this iterative cycle to continue to persist and potentially impact future programs or iterations of programs that we have at the Alliance. And finally, it's really important for us to understand what impact we're having. So working with our early adopters to help them develop metrics and report on the tangible outcomes will help in building the case for continued support, capture the early program wins, and understand the measurable impact that FireSat's having. Additionally, this will help us build those use cases for, as I talked about in the timeline, that 2028 timeframe when the early adopter program kind of sunsets. We've got use cases for different landscapes, different regions, different data applications that can be used to like scale the program out to more users globally. And in order to make sure that we're not doing too much, too soon, too fast, too quick, we have established the early adopter network into 3 specific categories. Again, these really align with the user needs and some dedicated outcomes that we want to see with each of these communities. So the first is the operational, and this is really using FireSat data for integration into fire management practices. So this again aligns with those frontline and incident commanders, those on boots on the ground, and how they could use FireSat data to, as it says in the outcome there, identify strategies, decisions, and management practices that can be enhanced or enabled by FireSat data. Our second community is the modeling community, which is really using FireSat data for measuring impacts on ecosystems and climate. So this is working with fire scientists, fire behavior analysts, climate modelers, climate scientists, to really understand what this new source of data will do in helping to understand wildfire impacts, understand fire ecology, understand climate impacts, and carbon emissions from wildfires. So our outcome there is to advance the analytic use of FireSat data for more comprehensive models of fire behavior and impacts. And then our third category is for the technologies and tools that integrate with FireSat. And this is really about enabling wide-scale distribution and additional use cases of other technology and data that's coming online over the next couple of years. We know that the fire technology ecosystem is diverse, and there's a lot of different tools and technologies out there. And we'd love, as a nonprofit and as our mission and vision of enabling transformative fire data, we want to work with other communities to figure out how FireSat data enables those systems, and whether that be in federal programs or global programs that are coming online, or whether those be in fire tech startups. We really want to figure out how we streamline data distribution, access, and interoperability while exploring additional constellation, while we're exploring how the constellation builds out over the next couple of years and supporting other systems that are coming online. And this is my last slide before I wrap up and turn it over for questions. I see there's already a couple of things in the chat. But as I've talked about in sort of the systematic rollout and operational capabilities of the system, the early adopter program also focuses on key specific regions. And it really falls into kind of these 2 categories. One is the low latency data region, which is based on the capacity of the satellites and the ground stations. And this is really aligned with our operational data users that were in that first category of the previous slide. So right now, our low latency data regions, which will have basically near real-time data access to the initial operating capability of the satellite next year, are in the Western continental US, Eastern Australia, and Southern Europe. Additionally, we know there are regions that can benefit immediately from even daily monitoring of their regions and the impacts of fire. So we've prioritized regions in the Amazon basin, the Boreal, and Indonesia as categories where we will do the daily analysis and collection of impacts and monitoring of fire. It just won't necessarily be in near real time, but we're committed to collecting those and working with fire scientists and modelers in those regions to really start to understand the impact of FireSat data. Now, these are just the initial adopter regions. There will be capacity and ability to expand these regions, but to start out in the framing, I just wanted to kind of put this up there to for this community to think about the applications and use of FireSat data in these regions. So as I promised, that was my last slide, and I'm pretty much right on time. So the last thing that I want to do before turning it over to Claire to facilitate some questions and answers is just to thank everybody who stands behind me in this presentation, beside me in this presentation, the fabulous team that's behind everything that's being done at the Alliance. We are small but mighty, as one of our team members will always say. And we are committed and passionate about getting this work done. And I've never worked with a more passionate group of people in my life. So I just want to thank all of them who I'm representing today. And then thank all our philanthropic supporters as well. So this first phase of the program is all philanthropically funded, and the feasibility phases. So we've had some great support from folks like the Gordon and Betty Moore Foundation, the Environmental Defense Fund, Google Research, the Minderoo Foundation, and others who have been instrumental in getting us to where we are today. So I didn't want to leave without thanking my team and thanking the supporters that we have behind us. So with that, I'll stop sharing my screen and hand it over to Claire. And thank you all for taking the time today.
Thank you so much, Ann. Fantastic. Well, let's dive into some questions because I know folks have some burning asks. I know Alex has the first one around 7 meters per pixel. So I don't know if you have an answer to that first question.
Yeah, so we are at 50 meter per pixel resolution when we're directly near. So directly overhead, we're at 50 meters. We have a 1,500 kilometer swath width of the instrument. So when we get to the edges of that swath, we have not as good of resolution, but we're about 100 meters when we're at the edges. So we say we're at an 80 meter average resolution per pixel for the instrument design.
Great. And then Kirk has a question on firefighters and firefighting and how those folks that are active firefighters fit into the alliance.
Yeah, so hopefully I answered that a little bit in the end of my presentation there. So they fit into the operational early adopter category that will eventually scale out to, global operational fire agencies and use of the data. So really, our goal was to deliver this data that's useful in both observation, spatial resolution, and temporal revisit to get this data down into the hands of those on the ground who can actually use this data in real-time operations. So we already have 8 fire agencies signed up globally in our early adopter program to work with us to figure out how to use this data in firefighting operations, and then how we can actually use that to scale out to other agencies. And we're looking at agencies that are a variety of different types. So obviously we know that there are volunteer or staffed. There are regional differences in firefighting strategies and maintenance. So we're trying to work with a variety of different categories of firefighters to make sure that we understand exactly how our data can be used and how we can deliver it in the most useful manners as possible.
And then we have some questions from Angel. How will the data be publicly available? And if so, how? And will it be granularly raw data for all bands, apart from hotspots? And how will the sign up be managed for early adopters?
Yeah, great questions. Lots of questions. So the data will be publicly available. So it's part of our commitment to, making sure that this data is equitably accessible to agencies around the world and fire researchers. How is very much in the works right now. So part of working with our early adopters is to understand what are the current mechanisms where data is accessed right now, and how can we integrate the data into those existing mechanisms, and how can we integrate into new mechanisms that are coming online. So ultimately FireSat wants to be a data aggregator and data distributor, but we want to work with the systems that are in place to do that. So as part of our early adopter program, and we just hired a data integration and data operations lead who will be the one responsible for making sure that we get this data into the different forms and file systems and mechanisms to get it ingested as easily as possible. There will be, so the different bands, the second question there, will the different bands be accessible? Yes. So we will provide both the raw data processed with the DN and calibration data, but essentially the brightness temperatures across all of the different bands, as well as those 4 data products of the perimeters, the hotspots, the fire progression, and the radiative power. And then how to sign up for being an early adopter? Reach out to me. So I'm the early adopter program lead. We are building up the program, over this next year. So feel free to reach out to me, either Ann at earthfirealliance.org, or if you go to our website, there's a sign up to be part of the community, which is community@earthfirealliance.org, and we'll be happy to talk to you more.
All right. And then Sean, it looks like your question was just answered, so that is great. And then Mary was wondering when Hawaii would be included, if there was a plan for some of those regions that weren't on that priority list. So maybe there could be just a little bit of a response to that.
Yeah. So, as I said, our goal is to get this global data out as quickly as possible. It's really a capacity and capability, concern as we continue to build the system out. But we are working with, partners, whether that be on the ground or funding partners, to figure out how quickly we can get everything, all the regions that want to be included, turned on in the low latency data as quickly as possible. Hawaii is definitely on our list, as well as Alaska, and sort of how do we expand that region in the kind of western continental US, and especially some key fire geographies of the last couple of years. And so absolutely it's on our radar, and as quickly as we can speed that time up, we are looking at all the mechanisms in order to be able to do that.
Great, thank you. And then you are getting kudos from Rob. And then he's also pondering if there are any potential for smoke plume tracking capabilities as a part of this effort, and seems like it would be a great complement to the fire detection.
Yeah. So hi, Rob. Thanks. So absolutely, there are, what we talk about and what we've planned for the system is just scratching the surface of what we know the capabilities of a multispectral imager, specifically tuned to fire, will be able to do. We are focused and committed first to delivering kind of the core fire data and fire data products. But part of working with this community is making sure that we can find other applications of this data and other ways to use it in modeling and fire behavior dynamics, to better understand kind of what's happening. And I think smoke tracking is absolutely one of those use cases, as well as some of the pre and post fire condition monitoring for fuels, and some of the land management practices are some of the highly promising studies that we want to get into and find those that are kind of working on that in our program. So yes, and as much as we designed the 5 spectral bands to be able to see through smoke, we also have it that sees smoke. So we will be able to do some smoke tracking, I think, right off the bat with our capability.
Okay, great. And then Kimberly was wondering, also providing kudos, when and how will you address mitigation measurement effectiveness?
Yeah, great. Thanks, Kim, or Kimberly. And yeah, I mean, it kind of goes exactly to the question that Rob said and that I just answered, is we want to understand the broader uses and application of FireSat data by working with communities that are the ones on the ground doing this. And I think, some of the measurement of how mitigations are being employed, how effective they are, will be something that we have to work with the community to understand where exactly those mitigations are taking place, when they're taking place, and then how can FireSat data kind of be used to monitor those, whether those be in-process mitigations or the effects of those throughout the fire season after those mitigations have been put in place. So it's definitely something, again, that we're not the experts in. Likely many of you in this community are, and in other communities, and it's part of building out the alliance to make sure that we're collaborating and working with others that we can enable better measurement and management through access to FireSat data.
And then Talbot had a question on the financial model and scaling long term.
Yep, great question. And if I had 2 hours in this presentation, I certainly would have gone into that. But it's one of the key questions. So as a nonprofit, we have an ambitious mission and vision here, but it can only be done by working through the mechanisms for funding that are available. Obviously, the build and the launch and the sustainment of the system isn't free. So working with the communities and figuring out a sustainment model for this has been a key component of establishing Earthfire Alliance and what we're doing. So I mentioned this at the end, but early on, the first 3 satellites, so that first capability that goes up next year is all philanthropically funded. And that's really for risk reduction and to build that case out for why this should be long-term sustained as a service. So sustained by governments and other kind of government service programs. And that can be done on a global scale. But we really needed that kickstart from the philanthropies to kind of build the first capability and see the use. And then we're building out the long-term sustainment and sustainability in the government sector. So we've got a strategy in place that evolves daily, it feels like, but really making sure that we've got that sustainment in mind, but using philanthropy as the Kickstarter for that.
Great, thank you so much, Ann. And I am sorry if we don't get to everybody's questions, but maybe I can select one more. David had a question on coverage for Canada. Is there a plan to integrate the Canadian Wildfire Sat?
Yes, great question, David, and hi. So yeah, it was, I didn't go into a lot of detail on the Pathways group that was in our early adopter program, but any group that's sort of building up capability, whether that be privately funded or government funded, are part of who we want to collaborate with in that Pathways program. So Canada's Wildfire Sat is probably the exemplar of our Pathways program, of figuring out how we can collaborate with them, how we can share resources and capabilities as more systems are kind of coming on board and in alignment with that. We will collect some of Canada initially in the Boreal region. So we're already working with some fire scientists and researchers in that region. When it scales to kind of real-time and operational use will be a little bit TBD and a little bit based on our collaboration with Canada. So.
Great. Thank you so much, Ann. And I think that you are receiving a lot of positive acknowledgement from the community. So this is fantastic. And just want to thank everybody for being here, being able to listen to today's conversation. And we hope that you can join us for our next session on July 31st at 10 a.m. Pacific. We're actually going to be talking through the Wildfire Commons launch, which we're going to be collaborating with the Earthfire Alliance on some of their data and other collaborators within this community. So we're looking forward to sharing that with you all. Ilka, is there anything else that you want to add before we close out today?
I just want to thank you, Ann, again, for participation in this great webinar today. And I think it speaks to the value of what's coming, all the positive comments you're doing, and indeed, data democratization and open data and science are really dear to our hearts in the Commons here. We are looking forward to working with you guys. Keith, also I see there. Nice to see you. Thanks for all your work on this and FireSat.
Fantastic. Thank you so much for the time and the opportunity to present here today. And please don't be shy. Reach out if there are any questions or anybody wants to collaborate. And hopefully this will be just the first of many conversations. So again, thank you so much for allowing us to speak today, and for all your attention and great questions. Appreciate y'all.
Thank you. Thank you all very much. We'll see you next time.